Okay.
From here, there's our uniform acceleration formula. Cross multiply, we get our v equals to u plus at.
Oh,
And then this is the average distance under the graph, right? Our displacement is distance under the velocity time graph. Okay, then recognize this one is stationary, uniform velocity, displacement time graph, velocity time graph. Uniform acceleration is a parabola, velocity time graph, acceleration constant. Right? This one is increasing acceleration. This is decreasing acceleration. Right? Not deceleration. The value of acceleration decreases as well. Right? And now this formula you need to know how to use it. Okay, number one, the graph shows a variation with time of velocity of a trolley initially projected up an inclined runway. That's an inclined runway. What is the maximum distance up the slope and the trolley reaches? How to calculate?
area under graph.
Area in the graph. Okay, what's your answer? That area of triangle. Right? This is going up. Make sure you know what this is going up. This is going down.
Yep.
Right? Maximum distance area under the graph. Shaded area half 0.8 times your base 0.2, 2.5, 1.0 B. Okay with that?
Yep.
This one, read carefully. What is the rate of change of momentum when a force of 4 Newton acts on a mass of 2 kg at a time of 2 seconds? Answer, you should take
Rate of change of
Yep, it's a tricky question. Just to test you.
momentum is the force. No?
Rate of change of momentum is the force. So your answer is C. Okay now.
Yeah.
It's a catch, there's nothing to calculate. Number 3, a steel ball is held above a horizontal table and released so that it falls on the table and rebounds several times. The collision are inelastic. Which graph best represent the variation with time t of the acceleration A of the ball? Yep. Memory work.
D.
Donkey.
Oh, yeah.
This part is where it's in the air. This part is when it hit the table. Okay. Let's try this one. Question 4. The graph shows the variation with time t of the displacement of particle moving along a track. Which graph best represent the variation with time t of the velocity of the particle? Yep. Look at the gradient. Gradient is a velocity. Where's the gradient 0? Where's the gradient maximum? Where's the gradient negative? So what's the answer?
A.
No,
Oh, wait.
it should be 3, 0. Velocity equals the gradient of tangent to the curve. Zero here,
Uh-huh.
zero at the top there. Sorry. Uh,
Oh yeah, I get it. I get it.
Zero at that point there. And maximum is at the center here. Maximum gradient is here positive. Maximum is minimum is maximum negative. Can?
Mhm.
Okay. How about this one? The graph shows a variation with time t of velocity of a bouncing ball released from rest. Downwards velocity are taken as positive. At which time does the ball reaches the maximum height after rebounding? This one you need to know your physics well lah.
Maximum height after bouncing is
Uh,
A. No,
no.
no, wait. Which time?
Maximum height velocity is zero ah.
Yeah, yeah. It's a B. I think it's B.
No, 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 no. You must understand where is your A, where is your B. A is where it hits the ground. Before it hits the ground, B is when it hits the ground. C is where it receives its maximum size again. It's still on the ground. And D is where answer is D. D is the maximum height. Okay now.
Oh, oh,
B
yeah,
is
yeah.
where it just touch the ground, it's compressed to B. And C it gain its shape completely with velocity. Then it leave the ground. Okay ah.
Yeah.
This one student always has problem one. A car is traveling along a straight road. The graph shows the variation with time of its acceleration during part of the journey. At which point on the graph does the car have its greatest velocity? Yep,
Greatest velocity,
greatest velocity.
highest acceleration.
Yeah, where's the answer?
Then, uh, I want to say B, but I think it's wrong.
Then what's the answer? What's the answer?
I think it's C. I think.
C, because it's accelerating from A, B, C is accelerating, accelerating magnitude is slower. After C is decelerating. Okay. Or area under the graph is displacement. Sorry, area under the graph is velocity, change in velocity. Okay, can
Can you explain? Because because
A, B, and C all
the
accelerating, except magnitude is smaller, that's all. After C is
uh
decelerating, negative acceleration means decelerating. Velocity start to decrease. Can A
B
velocity
is highest acceleration, but it does not mean it's the fastest, right?
after C is decelerating already. That means the speed of velocity decreases already. So
Oh,
C is where the maximum acceleration, maximum velocity. Lor. Okay,
the
now.
B is maximum acceleration.
After C is deceleration already because it's negative acceleration. The
All
speed of
right.
velocity decreases already.
Okay.
A particle is moving in a straight line with uniform acceleration. Which graph represents the motion of a particle? What does A represent? Yeah, A represents what?
Just distance, right? Velocity 0.
Velocity means stationary lah.
Yeah, stationary.
Yeah, how about B?
Constant velocity.
Okay, C.
C, wait, C. C is constant acceleration.
Uh, okay, answer is C lah. Can
Yep.
this one? Graph relates the motion of a falling body. Which is a correct description of the graph? Yep. What's your answer?
Falling.
Yep, yep. What is the answer?
Why should be speed?
What's your answer?
Speed and so it's D.
Donkey lor.
Donkey, yeah.
Donkey lah.
Yep.
Right? No air resistance, it would be a straight line. If it's a speed time graph, A is false, B is false, C is false. The answer is donkey. Okay, this one. A stone is thrown upwards from the top of a cliff. After reaching a maximum height, it falls back, falls past the cliff top into the sea. The graph shows how the vertical velocity of the stone varies with time t after being thrown upwards. R and S are magnitude of the area of the two triangles. What's the height of the cliff above the sea? Yep,
Isn't it just S?
answer.
B.
I understand your problem. S is going up from the max from the cliff. That's your cliff. That's your S. Then R is from the maximum height to the bottom. That's your R. So donkey, correct? Oh? Okay,
Oh, throw my outwards. Okay.
this one. A tennis ball is released from rest at the top of a tall building. Which graph best represents the variation with time t of the acceleration A of the ball as it falls, assuming the effect of air resistance is appreciable?
What's that? What's appreciable?
Air resistance cannot be neglected lah. Got air resistance, especially the tall building, then you have to consider air resistance. Yep. Answer. Memory work.
D.
Donkey. Yep. Initially, acceleration is g. As air resistance increases with velocity, the acceleration decreases or g decreases to almost zero. Okay?
Teacher,
Yeah.
Whiskers drag is the drag inside the water, right?
Viscous drag, usually we use it for water lor.
Water.
Ah,
Oh,
the
so
same
drag
lah.
is in the
Instead of call it air resistant, or sometimes we call it friction lor, or viscous drag lor.
okay.
Okay, how about this one? A body falls from rest in a vacuum near the Earth's surface. The variation with time t of its speed v is shown below. Which graph shows the variation with time t of the speed of the same ball in air at the same place on Earth? Yep. Trick is there is air resistance lah. Second part, first part no air resistance lah.
It's similar to air resistor.
The first part is no air resistance lah. That's why they call it vacuum ah.
Oh, so
Then
second part got air resistance.
second part air resistance lor. Air resistance is not negligible.
A.
No, cannot be straight line here. It is only straight. It's only straight initially. After that, it go further and further away until it become constant the terminal velocity. Okay,
Oh. Okay, but isn't A and D kind of the same?
different. A shows you that as velocity increases, it's still a straight line. Whereas this one show you as the velocity increase more and more, air resistance becomes significant. So it go further and further away already, the velocity. Cannot be a straight line like that. Initially straight line only. After that, it go further and further away.
Okay.
Okay. Okay, let's go to the next question. This one is a bit tricky. A ball is released from rest above a horizontal surface. The graph shows the variation with time of its velocity. Area x and y are equal. This is because, yep, there's a catch here lah. All, all the all the answer is correct lah. Except there's a catch here lah. What's the answer?
Okay.
Yep. The catch is the hint is area than the graph lah.
Yeah, but
All answer correct. Except the catch is they want area under the graph. What's area x and y equal? Okay now.
distance. Area X and Y is the distance.
X and y area is same distance same displacement donkey lor. Area under the graph for
Same
velocity time graph is displacement. Downward is taken as positive. Okay, can
Teacher, but this is a vertical component. How can it bounce up and still be the same?
where where it rebounds the velocity this is where this is where it hits the surface. This is where it's going up. And maximum height, no air resistance, maximum height. Then in reverse direction, coming down, it's coming down, it's going up. Okay, ask if you not understand us. Area under the graph is
No, I'm just
area under the graph is a displacement.
But how is it the same displacement?
What do you mean? How is it explained? Area in the graph is a distance. This is where it's
No, I
going up.
mean,
This part is where it's going up. Ball is rising. Maximum height 0. Then it's coming down. No air resistance. So these two areas should be the same because they are same height. Same height. Yep, yep, yep. What is causing the problem? Ask until you are happy with it.
X is going up, right?
X is going up. Y is coming down. No air resistance. Only
Oh,
during the only during the impact the velocity changes as well.
hmm. Okay.
So the next one you should be able to draw lah. Right? Acceleration time graph. Try this one. The diagram shows a velocity time graph of a mass moving up and down at the end of a spring. Each point represents the velocity of the mass at its lowest point of its motion. This one is simple harmonic motion. I can see they can use different graph. Sometimes some of the teacher may not have teach you this. So you have to use what you have learned in your SPM no? Or O level. No? Yep. Can
What's the point?
I identify that A is at the rest position where it's not moving lah. Then you pull it down. Velocity is 0. At time equals 0. Donkey. Then it will accelerate upwards. So. And then the acceleration start to decrease. And right, so A is velocity is maximum. Right? This where velocity is maximum. It's moving downwards. Sorry, it's moving upwards. The maximum height velocity is 0. B, then it coming down. Velocity increases to maximum again. C, and got D goes to 0 again. No? That's why it doesn't move anymore. Velocity is 0. No? Can.
Hmm.
Okay. This one show you what is happening lah. There's your A is moving upwards there. Right, we got 10 more minutes left. How about this one? A particle move along a straight line. Particular property K of the particle's motion is plotted against time. At any time, the slope of the graph is the acceleration of the particle. What's the property K? This is simple harmonic motion, which you study in A2. Yep.
What type of motion is this?
Don't worry about motion. They ask you to use your knowledge of AS that you have learned to identify K. What is K? Is it displacement, distance, speed, or velocity? Huh? They give you idea. Slope of the graph is acceleration of the particle.
Should be should be D.
Donkey. Pendulum oscillating, what type of motion? Pendulum oscillating, where's the particle initially? Particle is there. Negative x direction, oscillating to and fro. Right? Where the velocity is zero at this point. That one is A2 lah. You don't have to worry. You just need to know how to identify K and so. Okay, what's the answer? Graph shows the velocity time plot of two vehicle X and Y. Acceleration and distances traveled by the two vehicles can be estimated from this plot. Which statement is correct? Yep.
Hmm.
A and B cannot be right because we know straight away that the acceleration is different. Acceleration is a gradient.
Yeah.
Right? So it's either C or D. So calculate out for X, area of triangle, for Y, distance travel 0.5. So C is wrong. Distance is the same. Distance traveled by X is greater than traveled by Y. So answer is donkey. Yep. Both distance are the same. Can
Can.
this one? A sphere is released and falls. Its initial acceleration reduces until it eventually begins to travel at a constant terminal velocity, which displacement time graph best represent the motion of the speed of the sphere. Sorry. Yep. Can
Constant terminal velocity.
constant terminal velocity here.
Yeah.
Yeah. It will
Okay.
be. It's just a parabola initially. I said it's lower. Parabola is that way. Right? It's further and further away, and then becomes a straight line when terminal velocity is reached. Okay, now donkey answer.
Hmm.
This one. A steel ball falls freely under gravity after being released from rest. Which graph represent the variation with height of the ball at time t?
Yeah. Oh, wait. Is
Use
that right?
gradient. When you drop a ball, the velocity increases. So the gradient will give you the velocity. No? Velocity will cut to increase to a maximum where you reach the ground. Yep, that's the answer. B. No? Right? Since the ball is dropped from a height h, it must be initially at a maximum height. So it cannot be donkey.
Yeah.
Velocity is gradient of tangent to the graph. The velocity increases This velocity is constant. Right? This one, the gradient start to decrease, so velocity decreases. This one, velocity increases. So answer is B. Can.
Hmm.
Try this one. The graph shows the velocity time graph of a vehicle. The diagram shows the velocity time graph of a vehicle. The vehicle is moving at 4.0 meter per second. Begins to accelerate at time t equals 0. What is the vehicle acceleration at time t equals 3 seconds? Yep. Draw a tangent to the graph, no? Yeah. You can work on the paper after all and then calculate out. Lo. Use a big triangle. Can.
Hmm.
A student throws a ball in a positive direction, vertically upwards. The ball makes an elastic collision with the ceiling and rebounds and accelerates back to the student's hand in 1.2 seconds. Which graph best represent the acceleration of the ball from the moment it leaves the hand to the instant just before it returns to the hand? Yep. Taking upwards as positive, you want the acceleration time graph. Yep. What's the answer? At the ceiling, the force on the ceiling decelerates. Right? Donkey, no? G is always negative. So when it hits the roof, the ceiling will provide another downward force. So
Oh, is that why the
there's a sharp there where it hit the ceiling.
oh
Same
okay.
direction as G. Okay,
Hmm.
how about this one? A boy throws a ball vertically outwards. It rises to a maximum height where it is momentarily at rest and falls back to his hand. Which of the following gives the acceleration of the ball at various stages in its motion, taking vertically outwards as positive, neglecting air resistance?